Here I outline the verification steps. The most basic thing to do is to perform sanity checks on one's results, and we have been doing that as we have looked at the velocity contours, the pressure contours, the velocity vectors, etc. So we have done quite a bit of that. The next thing to look at is, does the CFD solution honor the boundary conditions in the mathematical model? And that is, we're looking at whether we input the right boundary conditions into the tool. And we have been, we checked the velocity boundary conditions at the inlet and at the wall. We've looked at the pressure boundary condition at the outlet. So we've done a fair bit of that. So we can be fairly confident that we have input the right boundary conditions into the tool. Next, we look at, does the CFD solution honor the physical principles in the mathematical model? And the physical principles are conservation of mass and conservation of momentum. So, and if mass and momentum are conserved for each cell, then it has to be conserved for the entire domain. So we can check mass and momentum conservation of the entire domain. And there's a straightforward way to check mass conservation of the domain. So we will do that. Momentum conservation we can do, but we'll have to write expressions in CFD post. It's more involved. And so we will not do that, with the understanding that if we want to do this more thoroughly, then we should do that. Then we're moving on to checking the level of numerical error. So is the linearization error acceptable? And so we can check, if we go from the residuals falling to 10 to the power of minus 6 to actually falling 10 to the power of minus 9, how does the drag coefficient change? And I will let you check that. And also, actually, when you're checking mass conservation, momentum conservation, if they are satisfied, then we have a reasonable solution. Then the linearization error must be small, because if the linearization error is large, mass and momentum won't be conserved, because we don't have a good solution to the algebraic equations. And then the other big numerical error is the discretization error, and that we can check by performing mesh refinement studies. And so we will do that over here. Finally, does the CFD solution match the analytical solution in the fully developed region? That's another check on, whether we have solved the mathematical model right. And we already checked the velocity profile. We could also check the skin friction coefficient, but we'll stick with the velocity profile here. So we've done that, and let's check mass conservation, and let's do mesh refinement.